Hello, everyone. Welcome to the Engineering Bart Show. Yes. I hope you enjoyed the little intro. I'm going to put some timestamps so we can get. I know some of you guys get antsy and you guys only want to see small parts of the presentation. But today what we're going to do is we're going to install two LEDs with any color. Turn one LED on for a second, LED off for a second. We're going to run the device's source and then sync. We're going to explain that concept. And you can use any MBed device. And we're going to use the MBed Operating Studio. All right, so stop, design, build the code. So this gives you a chance to stop, code it your own way. If you don't know how to do it, that's fine. Let's go ahead and go on the next one. So the lesson, we're going to talk about commands. Very simple. Digital out, name it, PC, whatever. PC is 0 up to 15. And that's one sourcing. It's the same thing for syncing too. I define seconds as 1 million. That's 1 million microseconds. And that's, we're going to convert that to seconds. Okay. And okay, we're going to talk about this wait US microsecond inline second. This is a wait feature. It's a friend at the very beginning. I've been doing this for a little while, but this thing can be really painful when your device, when you want to expand your projects, do something a little bit more sophisticated. And so it works great at the beginning, but then as it progresses, it becomes sort of a hindrance. Why it does that? Because what it does is the wait, it will paralyze the microcontroller, meaning it doesn't function until the time's up. So when it's on for 1 second, it is paralyzed. No data can come in at that moment. That's off. No data can come in for that moment. So if you're using a device for a multiple data processing machine, this feature right here may be your culprit. But till then, we're going to enjoy this wait. All right. So hello. So we're going to go to the syncing versus sourcing circuit analysis on our. So we have. Let's talk about sourcing. If I spelled that right. So your MBed or Arduino, whatever it is, it doesn't matter. It's going to be attached to it, okay? And then basically there's going to be a diode right here, okay? And there's going to be an R, which goes to ground, okay? That goes to ground. So, okay, and since we got multiple ports, we don't need to tie it up. We're just going to tie it into a port. Okay. Now we have an R here. We want to limit our current by sourcing. You want to substitute. So now your MBed becomes a battery. Okay. And it too is grounded, so that's the ground. Also, current is going to flow from positive to negative. Current will flow, electrons flow to negative to positive. We have an R here, and we have this diode. Let's say it's red. It's a red diode. Say this is a red diode. Yellow diode could be slightly different. So we know that it's good. This is how it hooks, but what is this R right here? How can we protect our circuit? Because we want a current limiting resistor. It will accept, when it's sourcing, it will accept without a resistor. It's not advisable. And then by syncing, you have to put it in a resistor. So, but as on the past videos, we learned two things. One, there's 3.3 volts coming out. So now we know 3.3 volts. Okay? So but what about the current? Do we know anything about the current? Well, in my last video, we don't want the current to be above 10 milliamps. So the I is 10 milliamps. Okay? 10 milliamps. That's the maximum. No, I think it could go more than that, but I read 10. If someone wants to challenge me, by all means, there's a comment down there. Go ahead and do it. Okay. So, we got a voltage here, 3.3 volts. We got an I here, okay, which is 10 milliamps, so it's 0.010, okay, amp, okay. And so we know that we have Ohm's law, V over R equals I, so therefore we want V over I equals R. Okay, so we know that. However, we have this diode right here. There's a diode that gets a drop. So rather what we do, we substitute the diode for a battery. Okay? For a battery. Say it's about a 1.1 volt battery. Okay? So let's think. All right. So it's going to go minus, plus, minus, minus. So the voltage is minuses, and we got 3.3 volts minus 1.1 volts over 0.010. All right, since I'm not like, I take math, but I don't like dream about math, I gotta use a calculator. All right, so 3.3 minus 1.1, okay. Okay, so answer, all right. 0.010 is, it's about 220 ohms. I like to do about, you could do about 300 ohms, so it's 300 ohms, excuse me. 300 ohms. So 200, anyways, it's that right there. So you could use a 300 ohm, 220 ohms, kind of that resistor. So your resistor is 300 ohms to 330 ohms, around there. Something like that. So I would put that in. Now, we talked about sourcing. Now let's talk about syncing. Syncing is the same thing, except now your MBed is now equal to a ground. Okay? And now you have an outside source, or you could use that, you have an outside source that's doing this number right here, and then there's a battery right here. Okay, so now your embed's ground. So it's very important that when you use a power supply, even if it's 3.3 volts, that your current, when it flows into the MBed, it's going to go right into the MBed and into the chip itself. Okay, and the chip is pretty small. It can't handle a lot of voltage or current. So that's why it's very important to keep it below 10 milliamps. I think it's 50, something like that. Okay. This is AutoCAD. I already have all this stuff already built, and so this sort of gives you an idea what the circuit will look like. So I have, okay, so we're going to have, we'll do this one. Put on that. Okay, we want a line. Let's have a line from the ground. Let's put ortho on. Okay. And, okay. There's that right there. I like to put in a little circle. That kind of lets me know that that's kind of the node of it. Oops. Okay. So let's move, enter. Oops. Bugger got away from me. All right, so let's do this. Solid. Hatch. Nope. Solid. There. That's ground. Now we want PC0, PC1 are over here. So let's go ahead and do a line. Let's turn ortho on. That's really cool. Ortho's cool. Click. All right. And then there, click. There. Let's get it right about here. Click. Right about here. Click. Oops. Okay, we're doing it live, so you got to bear with me. All right. Line over here. Okay, click. Click. And click and click. Perfect. Okay. And then we're going to do a line right here. Click, and click. Enter. And we're going to do a line right here. Click. So we're building a circuit. You guys are probably building it by physically building it, but this is that looks kind of. Let's kind of put a little node right there. I like to do a little hatch in that thing. Solid. Enter. I like that. Let's go ahead and copy it. That's what I'll do. Let's take ortho off. We're going to copy. One, two. Okay, enter. And then we're going to move it. This kind of shows that it's connected, you know what I mean? It just says that it's connected. So there's no ambiguity if it's connected or not. But those nodes will come into play when the circuit gets a lot more complicated. Okay, let's go ahead and copy more of these guys. 1, 2, 3, I would say. Move from here. Kind of like this. This says it's connected together, you know. Move from here. Okay. And now let's put, where's my ground? Let's make some more of those things. Copy. 1, 2, 3. Okay. Move it. So let's go create a line. Let's see if we can get the center point, midpoint. Nah, that'll work. Okay, let's put ortho on because it's really cool. Okay, I like ortho because I kind of line it up with the crosshairs and bam, and it just snaps together. Enter. We want to move a node because that says it's connected. So move it from here to here. Okay. Let's just go ahead and move this. Let's use the rest of these things to say it's connected. Okay. Last thing, we're going to fill up the hatch so it looks pretty cool. So here's the hatch. Solid. Okay. That's because this was done. You have to really kind of get in there. Okay. Oop. Undo. Okay. Sometimes it's a little bit fickle. There. Got you. Okay. Where is it? There it is. Okay, we're going to do the same thing. There. See, it looks cool. So now it's PC1, PC0. We got it grounded. We got the 2 LEDs on, 330 ohms. That's connected ground. That's it. It's about as simple as it gets. And now let's go to the software part. Okay. Okay, so now we're going to start the pseudo code. We're going to declare our pins, and we'll declare them. I have a red LED, yellow LED. You may have different colors. That's okay. Run forever. Red LED turns on, yellow LED turns off. Wait for a second. Red LED turns off, red LED turns on. Let me add this. You also want to wait for 1 second to turn off. I'm going to we're going to talk about, okay, so that basically that's what it is. So let's go to the IDE where we've already got this thing started up. So we're going to do a new program, select, empty embed program. We're going to erase all this stuff right here. We're going to put simple because that's where we're at. We're not doing anything complicated, not yet. Simple 2 LED. Okay. I like to do underscores. You could do, that's how I do it, but okay. And see, let it kind of load it up. It's loading. It imports every library through every file, so it kind of takes a while. It puts a lot of stuff through each project. So hang tight. There we go. Let's try to find it. I think I found it. Okay, and it's right here. You want to click the main.cpp. Main.cpp. There are other files here you can mess with, but that's, that's at your own discretion. It's always a good idea to comment your code. I use the Java standard. So the Java standard means you put 2 asterisks on one side, and then right here, put your name down. It's Andrew Dunlop A.K. Engineering. Engineering Bard. Yes, that's me. Okay. And then we're going to turn on red LED, then off yellow LED for 1 second. 1 second. Then vice versa. On other videos, when they get complicated, I'm probably going to type all that stuff up, but this is so easy. I can just type it as is. 5-20, 25. Holy smokes. And now let's go ahead and let's go ahead right here is the global area. This is the sort of the global area. That's what I was taught. Global area. This is where you want to declare your pins in this area right here. Not in the main, before the main. Let's declare global area. Let's declare pins. I'm only going to do this once because I assume we can understand that. So digital out. And then digital out. Let's call it red LED. And I chose PC 0. There it is. Sometimes it just shows up, Semicolon. We're going to do it again. Digital out. Yellow LED. And PC-1. Okay. That's it. Well, no, actually I lied. Let's go ahead, hashtag define second as 1 million. 1 million microseconds. Microseconds. Hashtag define on as 1, hashtag define off as 0. Okay, and that's pretty much it. This kind of makes help everything read a bit easier. And you know, and it's really what I love about this is really what it kind of says. It's nothing all that fancy. Well, it is. It's just, it looks pretty simple, but it's designed for simplicity. And then we want to wait. There it is. See, it kind of has this, kind of works a bit like Eclipse. So like Eclipse, it sort of builds it in. You know, it's exactly what I said on the piece of paper, what it was before, you know. I mean, we're coding, folks. I mean, it's pretty simple stuff, but we're still coding. See, I'm going to paste it. We're going to do the opposite. Okay. And basically, I've already got this compiled, but basically that's it. You know, you shouldn't have to copy and paste it. It's pretty simple stuff. All right, so thank you. And I have a little bit of a disclaimer, but copy it and run it, and we'll see what it goes.
Okay, so there you go. Red, yellow, red, yellow. Hope you guys see that. All right, now that's basically the source code. Let's go ahead and let's look at the syncing code. All right, so here is the red LEDs, but this is in syncing mode. Notice the power supply is on. The orientation is exactly the opposite. So just keep that in mind, but this is in syncing mode. Thank you. Okay, so this is the disclaimer act for the end of my video here. I'm probably going to do this on all my videos. It'll be exactly the same. I'm going to keep the same one. This channel is basically, it's an open source channel. However, as we progress, I've noticed that if I even do a couple songs, even do a cover songs, there'll be a Copyright Protection Act on it. And that's okay, but I'd be concerned if there's a copyright on my engineering side. So, because I want everyone this to be open source. I want everyone to enjoy the content without having YouTube say, no, I'm not going to be all that. So everything is going to be open source as much as I can, including the music and all that. If I get too many copyright warnings, I haven't got a strike, I will have to put this in the private department or maybe in some sort of website. I don't know. Please subscribe to my channel. The reason why I want you guys to subscribe to my channel is not that I want to make $1 million, but if you subscribe to my channel, it will improve that there is a demand for this channel. I believe, and I will try to create the best content that I can think of. If this channel, which I believe it would, we could combine music and engineering, and I believe if you combine that, then you could I could get other people to volunteer or hire them, which is good for the community. I'm doing this as sort of a non-profit. I don't make any money off of this. So please subscribe. It's not right there. It's just a little button. Just a little bit. Just the black button. Hit the black button. That's all it is. I won't tell anybody. It'll be our secret. But if you want me to, I'll holler it out. So, hope you enjoy my content, and there'll be more to come.